Hi students, in this video we will discuss about the Lenz law. What is the Lenz law? It is not an independent law, it is simply a very intelligent interpretation of the Faraday law of electromagnetic induction. In the Faraday law of electromagnetic induction, we are having EMF is equal to minus d phi by dt. What this minus sign is signifying? This particular thing only has been interpreted by Lenz in a very intelligent way, and he has given a law to find the direction of the induced EMF. Lenz law is used to find the direction of the induced EMF. It is used to find the direction of the induced EMF. It is in consistence with the energy conservation law. Remember, it is not an independent law, it is an intelligent interpretation of the Faraday law of electromagnetic induction. What is this law? According to this law, any magnetic effect will take place in such a way that it opposes the cause. Any magnetic effect is because of some cause. Any effect will be because of some cause. Say for example, if the cause is the changing magnetic field, then because of that changing magnetic field, EMF developed. Because of that EMF, current will be there, because that is the cause. So effect is the time varying magnetic field and cause is something. So any magnetic effect will take place in such a way that it opposes the cause. Cause will be opposed by the effect. This is the statement of the Lenz law, and this is a very simple and very important statement. Now take one particular example. Say for example, we have an infinite long current carrying conductor, and here we have one conducting loop. If this current is varying with time, say this current is increasing with time, it is increasing with time, and it has been asked from you, find the direction of induced current in this loop. Find the direction of induced current in this loop. Then how you will find why the current is getting induced and what is the direction. Now due to this current carrying wire, some magnetic field is present at the different location of this loop. That magnetic field is out of the plane of the paper. The direction of the magnetic field is this, and this magnetic field is depending on this current. When this current is changing with time, then this magnetic field is varying with time. Because of this magnetic field, a flux is linked with it. A flux is linked with this wire. It means this magnetic field is varying with time, so the flux is also varying with time. As this flux is varying with time, an EMF is induced in the wire, and because of this induced EMF, a current is going to be flowing in this particular loop. We have to find the direction of this induced current. Now what is the cause? Increasing current. Cause is increasing current. And this increasing current is causing a magnetic field, increasing magnetic field out of the plane of the paper. So this induced EMF, which is the effect, induced EMF, or I can say induced current, what it want to do? Induced current will try to decrease this field. It is an increasing field, so induced current will produce a magnetic field which will try to decrease it. So if it is increasing in outward direction, field in this direction is increasing, so the induced current has to produce the magnetic field in this direction. And when the induced current will produce the magnetic field in this direction, when the induced current will be in this direction. So the direction of induced current will be clockwise as seen from the top. Right? I hope this point clear. Now take another example. Let's take this question. In this question, one coil is there, conducting coil, near to which bar magnet is placed. north pole of the bar magnet is nearer to the coil, and the bar magnet is moving away from the coil. Bar magnet is moving away from the coil, and we have to find the direction of the induced current in the coil, right? So here what is happening, due to this bar magnet, magnetic field is present at the location of the coil. That magnetic field is towards the left. As this bar magnet is moving away, this original magnetic field is decreasing with time. So the cos is decreasing field towards left. So the induced current will produce a magnetic field which is towards left, and for induced current to produce the magnetic field towards left, the current has to be in this direction. That is, as seen from here, it has to be in the clockwise direction. So cos is the decreasing field towards left, so the effect will be, that is the induced current will be in the anti-clockwise direction as seen from the left. So induced current is in anti-clockwise direction as seen from towards left. Take another question. Two coils are there carrying constant current I1 and I2. Now these two coils are moving away from each other. These two coils are moving away from each other. We have to find how the current in the two coils are changing. Means total current in the coil left one, say coil A and coil B. So they are increasing or decreasing. Now here what is the concept? Coil A is placed in the magnetic field produced by B and vice versa. Due to this coil, due to the current in the coil B, the magnetic field is towards this direction. So original magnetic field towards this. And due to the current in this coil, current in A, magnetic field at the location of B is towards left. So this is B1, say, and B2. So original field for A is towards left, right, and for B is towards left. When they move towards away from each other, B1 and B2 will decrease. If they will decrease, the current will be in such a way, it will try to increase. Induced current will try to increase B1. So induced current want to increase B1, then the induced current in the A, for coil A I am talking, induced current in A will be towards this direction, this way. If we are seeing from the left side, it has to be clockwise. So direction of induced current has to be clockwise in A. And in B, if we see, then for B it has to increase. The magnetic field due to induced current has to be towards left only. So it is possible if the induced current here will be in this direction. So induced current will be anti-clockwise. Now if you see the arrow, I am marking the induced current by small letter I1 and I2. So capital I1 and small I1, that is the original current, and the induced current are in the opposite direction. So the net current in coil A decreases. Same way I2 and small I2 induced current are in the opposite direction. So the net current in coil B also decreases. So current in A and B is decreasing. Take another question. This is simplest among these three. We have one magnetic field, uniform magnetic field, which is decreasing with time. We have to find the direction of the induced current in this conducting loop. We have to find the direction of the induced current. So what is the concept? Here this loop is enclosing the magnetic field which is into the paper and decreasing. So the cause is decreasing field into the board. So the induced current has to oppose the cos. Cos is decreasing field. So induced current has to increase it, try to oppose this variation, oppose this decreasing field. So the induced current will be producing the magnetic field into the paper. So induced current has to produce the magnetic field into the paper means if the current will be in this direction, if induced current will be in this direction, it will produce the magnetic field into the board. So it will be clockwise direction. So the induced current will be clockwise direction. Let's take one more question. Let us consider one coil and another coil here, and this coil is connected with a resistor and a battery, and say here this is the front part and this is the back part. This black circled one is the back part, rear part. And let us say this resistance is varying, we are increasing the resistance. Resistance is increasing. Now we have to find what is the direction of induced EMF in A. We have to find direction of induced current in A. Right? Now when this current is there, current is moving this way and resistance is increasing. Resistance increasing means this current will decrease. Because of this current, here the magnetic field is there in this direction. And because of this decreasing current, this magnetic field will be decreasing. So the cause is decreasing field towards right. So the induced current has to be produce a magnetic field towards right. So induced current will produce magnetic field towards right, which is possible if the current in the coil A will be in this direction. If we see from the left side, it has to be in the clockwise direction. Clockwise as seen from left of the coil A. So this. I hope these questions have cleared the concept of the Lenz law. Only aim in this video is to find the direction of the induced current. Then we'll see in the next video about the self-induction, etc.